Hey there, everyone. So today I'm going to go through and go over again shaders with OpenGL and C++ and everything, and to kind of explain some stuff real quick. So this is a remake of the original video. Originally, when I did this, it's not on Twitch right now. It's not going to be on there. It's going to only be on YouTube. The reason I'm redoing this video is that when I went through and I originally did the shader video, I kind of just looked through things. I've done shaders before. I've done OpenGL before. I know it might not seem like it sometimes, but I can assure you I have. I have programs out there I've written for it. But the problem I ran into is that I haven't done it in a while. And so I kind of went through and was like, it'll be fine, I'll be okay. And I tried to use some new stuff, specifically string streams in C++, which a little bit different than Java. And that kind of threw me for a curveball. Some other stuff came in the way, and the video just took way too long. So this video is going to be similar to my live streams where I just kind of ad hoc it. I kind of just go with it and don't really worry about too much. I've gone through and actually set up the project on the screen right now to be exactly where it was when I did the video originally. And so there's some other little minor changes with the whole project. It's little things. I've restructured it, first of all, to have, I don't think this was in the second video. Actually, I think it was, so I'm not going to go over that. But basically, I've gone through and I've set it back to the state it was in when I did the shader video originally. And so what we're going to do is we're going to re-implement the shaders. And to prevent these issues in the future of me being unprepared, I'm actually going to be live streaming every week throughout the week, basically going over various things with my own game. I've been working on this game right here that is called Zombie Slayer Summit. It's just going to be a generic, fun little zombie first-person shooter. This is what we did on the last video, which you can actually see on YouTube right after this. But that's going to be a game I'm going to be working on in my spare time, and I'll be live streaming the development of that, which will be me learning to make sure that I'm ready for when I do the tutorials, which will still happen every Saturday, 3 p.m. Eastern Time Standard, noon Pacific Time Standard, West Coast people, and 8 p.m. GMT. So tune in on every Saturday for that on my Twitch stream until that Season 2 ends. But for the meantime, we're going to do this video. I'm going to go through and remake the shaders that we did before. This is going to be in C++, as you would guess, I guess, by the title. So let's jump right in. Let's talk about what shaders are to start with. So shaders are essentially bringing up an image here. So shaders are basically what are run on various parts of the data that you give to OpenGL. So when you go through and you render something, you have to first create your shapes. And your shapes are created out of what are called vertices. Vertices can make up triangles, they can make up quads, they can make up lines. There's very, very few primitive shapes that you can actually use. Generally, because GPUs are really, really good at rendering triangles, that's what we use. And that's generally what you should use. There's some other things as well called triangle strips and triangle fans, which are a little tricky to explain, but effectively a triangle fan fans out from a single point. So you declare one vertice, and what it will do is when you declare the second, the third, and the fourth, it will then create triangles based on those. So you'd have one triangle here and then one triangle here. I know that's a little tricky to understand, but there's not really a big use for those anymore. I kind of mentioned on the stream that they're good to use. They can be good to use to save data. Triangle strips are, you have a triangle point here, 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 and here, and if they're defined in that order, it will draw a triangle here, and then it will draw a triangle here. So it uses the last point as the last 2 points, basically. Sorry, in this case it would be weird. It would be 1, 2, 3. It uses the last 2 points to create a triangle. So those are a couple ways you can do that, but basically you just find these vertices, and that's how you create your shape. If you create a quad in that case, it would be 1, 2, 3, 4. A quad is just kind of a square, and then your vertices make up that square. And then lines are pretty obvious, and then there's points and some other ones. But we're not going to go over those. The big one to remember is triangles. So going from there, what ends up happening is each of the vertices are processed, and then those are put through into the Vertex shader right there. So we go from the Vertex data to the Vertex shader. And this is basically the Vertex shader, which is the first shader we're going to create, is basically just a program that's applied to each vertex. That's really all it is. So you can do things like move them around with the Vertex Shader. You can do all sorts of stuff, and then you pass them out to the next stage. The next stage goes through and actually makes the primitive, which you can see here. And this is where it'll actually create your triangle or whatever. Then, once you actually have that triangle, you have to create the actual graphics of that triangle. Remember, at this point, we just have the vertices and we have lines going between them, but there's space in between that's generally going to be filled in as well. And so this is what's called rasterization. This is where you basically get the pixels that are going to be used for that shape. So in this case, a triangle. Then those pixels are effectively put through the fragment shader. The pixels are really called fragments, and so each fragment has the fragment shader run on it, similar to the vertex shader. This is where you'll actually go through and do colors. So if you have a texture, you'll probably end up sampling the texture based on where it is, whereas if you want to just output a single color, you could do that too. Finally, you have some per fragment operations and such, and then the frame buffer, which is the actual image being output. Now, this is for OpenGL ES 2.0, so you might notice that on PC we have something called the geometry shader, and that would generally fit somewhere around this stage. It's generally performed on the actual shape itself. We're not going to cover that. The geometry shader is optional, and I really don't want to get into dealing with that at all. But that is an extra thing that's available. It's kind of a midway point between the vertex data and the fragment shader. So we're not going to go over that though. This image will be in the YouTube video, a link below the YouTube video. So this is kind of the stage. So there's a couple things we have to do to actually load in our vertex shader and our fragment shader. And I know it seems odd to be starting with this when we need the vertex data, but we can't display any of our vertex data until we have our shaders. And so we're going to do that. So the first thing I want to do is I kind of want to show some sample shader code. And so what we're actually going to do, ooh, uh-oh, is shader toy gone right now? That's kind of sad. Wow, of all the times to be down right now. I guess so. Well, hopefully that site will come back up. Shader Toy is a really neat little website where you can go through and play around with some shaders and such. But it looks like right now it's down. Hopefully that'll be corrected by the end of the video, but I'll include a link to that below as well. But basically you can write shader code with it and it'll go through and create it and render it. You don't have to worry about actually loading the shaders and everything else. It's a pretty cool site, especially if you want to play around with them. So I'll make sure both of those are in the links below in this video. So like I said, this has been rolled back to where we started the shader video originally. So what we're going to do is we're going to create a shader class. Now basically the way that this works is we have to load in our shaders, and then we have to load in our vertex and fragment shaders, and then we have to compile them and then create them into kind of a program of their own. And then we use that program whenever we want to render shapes. What's nice about this is you can have multiple shader programs and then use them for various models. So what we're going to do is we're going to start by coming over here and adding a new class, specifically a header file to start, and this is just going to be shader. So what we need to do is we need to include a few different things. The first thing we need to include is string, because we're going to be reading character data. Next we need to include string stream, which is a handy little thing for actually reading them. Then we need to include IO stream. Oops. And finally we need to include file stream, which is used for actually reading the files. So now we're going to go ahead and create shader class. And we're going to have some public things and some private things. I'm making sure all the code lines up with what I had in the next video. So we're going to have shader, string, vertex file name, and string fragment file name. Then we're going to have a Boolean value for use, and that's going to be it. For our private stuff, we need a few different things. We need the input file stream vert file for our vertex file. Then we need our fragment file. Next we need we're going to keep a hold on the file names. So we're going to keep the vertex file name, and we're also going to keep the fragment file name. Next we need to keep our string streams, and these are going to be vertex, source, stream, and fragment, source, stream. Next, we need the actual source code, which is going to be just a string, effectively, because it's just character data. That's kind of what's nice about this, is you can actually write these yourself. Finally, we need to store some integers to the Vertex Shader, Fragment Shader, and then the actual shader program as a whole. And then we're going to have a boolean for ready, which tells us if everything is ready. And we're going to have 3 separate methods. The first is to load our code. Then we're going to have a compile method. And then we're going to finally have a link method. So basically, the way that this works is we're going to load our source code, which is going to load up our Vertex file and then get the names. It's going to take in the Vertex source streams, and then it's going to read the code into these strings here. Then we're going to have compile, which is going to go through and compile our Vertex shaders and keep them pointing to these pointers here. And then once we've got them all compiled, we're going to link it together to form a shader program. So let's come over here. We're going to add a new item. In this case, it's going to be a C++ class, and it's going to be just shader C++. So let's go switch over to this. Now you might notice real quick that these are giving us a red error, and that's because Visual Studio, we haven't gone through and done our includes here yet, which we need to include windows.h, and we need to include gl/glue.h, and then finally we include shader.h. And what this is going to do is this is basically going to tell Visual Studio, hey, this file needs to, and you can see it's already gone from red to fine. Basically, because these headers are included before this header, this one is okay to use that glue in because they are defined above up here. And the only place that this header is included is right in here. So that is why that is okay. You can, of course, change this around by going through and doing this. I'm not doing that because I want to keep this code consistent, and that'll just make our life a little easier. So we're going to go ahead now, and we're going to end up adding in this using namespace std, which is just going to make our lives easier, so we're not repeatedly typing this in, because we do have a lot of that, because we're going to do some error handling. So the first thing is we need to do shader. We're going to have string vertex file name, string fragment file name. And what this is going to do is this is going to set our ready variable to false, and then our vertex file name to vertex file name there. And then this fragment file name is equal to fragment file name. Finally, we're going to do if this load is less than 1, cout error loading shader sources, and L, great, return, in which case we don't continue. If this compile is less than 1, then cout error compiling shader sources, and L, return. Finally, if this link less than 1, cout error linking shader program, and L. And that's going to be a little bit different from what you'll see next, so I'm actually going to do that to keep it consistent. And then finally, this ready is equal to true if all of that succeeds. So what this is going to do is it's going to set our shader to not be ready yet because we haven't actually loaded and compiled anything. We're going to set up our file names, and then we're going to load the shader and check that that succeeded. Then we're going to compile the shader, check that that succeeded. Then we're going to link the shader into a program, check that that succeeded. If all of these succeed and none of them end up reaching their if statement clauses, then we're going to go through into this and make our variable ready to true, signifying that our shader has been loaded. So the next thing we're going to do is we're going to come down and we're going to create our load method. So we're going to have int shader load. And what this is going to do is this is going to first take our vert file, and it's going to open it with the vertex file name, and it's going to use ISO in. And that's basically going to be saying, hey, we're reading this file, not writing to it. So then what we're going to do is we're going to check if that was successful. Vert file. then we're going to return -1 if we couldn't read the file. That might just mean the file's not there or something along those lines. If it is successful in loading it though, then we're going to open that into a source stream by doing vert file read buff. Then this frag file is also going to be opened in a similar manner. Fragment file name and ISO in. If not frag file, return -2 to identify it as a slightly different error. And if it's successful, then we're going to take that fragment source stream and we're going to read the frag file into there. Next, we want to get the source code, so we're going to take vertex source, which is going to be equal to this vertex source stream dot str, which reads it as a string. And we're going to do fragment source stream, not source stream. Fragment source is equal to this fragment source stream dot str as well. So basically, what this is doing. Oops, I named that wrong, didn't I? Fragment source. That would be why. So there's that. So what this is doing is, again, this is opening that. And then source stream is technically not a string, so we have to actually convert it to a string. The reason that we have this keeping around is because we need to make sure that this ends up outputting correctly. So now that we've gone ahead and we've done that, what we can do is we can come down here, and I'm making sure again that the code matches up properly, because the final thing we need to do is return 1 on success. So now that we've gone ahead and loaded the files, we have the source code in the form of vertex source and fragment source. What we need to do now is we need to actually compile the shaders. So we're going to do a few different things. This is going to be a lengthier method. The first thing is we're going to get a temporary source, and this is because it needs to be a C string, which is a different type of string. Remember, OpenGL, so to kind of start this off, OpenGL was designed for C. It's not really C++ friendly, so there's a lot of weird things you have to do, well, things that might seem weird, in order to get it to work. So first things first, we have to convert our string from a normal C++ string object into a array of characters for compatibility with C. Once we do that, then we can go ahead and get our shader created. So we have to create a pointer to our shader. So we do glGetShader, and we have to specify that that is a Vertex Shader. And so basically what this is doing is this is creating a pointer reference to our shader, which is then stored in that Vertex Shader variable there. Once we do that, then we can go ahead and compile the shader, then we need to add in the shader source. Now that we have the shader source, we can do Vertex Shader, because that's the one we're using. And then and temp source, and the length will be 0. So to kind of explain this method, and what we're going to do is we are going to go ahead and bring up the documentation for this. So glShader source takes in a few different variables, the first of which is this shader object handler. So this basically is that shader we created previously with glCreateShader. Once we do that, then we need to tell how many elements are in there. So we have a string, and we can actually have multiple strings within there to pass in as source code, but we only have one, which is why we're just going to say 1. When we pass it in the string, we have to make sure it's an array of pointers effectively, and so that's why we add that and in front of the string. And again, it's only 1, that's why that's 1. Finally, we have to tell the length of each of how many strings, specify an array of string lengths. In this case, we're only using that 1, so we can set that to 0, and that will be fine. To kind of explain this is kind of tough. Just know that that needs to be 0. So once we have that, we're going to take glint compiled, trying to keep this as short as possible, so I apologize if this is a little fast. The next thing we need to do is we need to go ahead and get the status of whether our shader compiled successfully. So what we're going to do is we're going to get this compile status here, and we're going to store it in the compiled variable. So basically what this is doing is we have this, I want to go ahead and move that over so you can read this more. We have a compiled variable here. We have this GetShaderIv. What this does, again, all of these links will be in the documentation below this YouTube video. So to keep things consistent, ooh, do we not have that referenced? I guess not. Wow, okay. I guess they only have that here for some reason. So the basic idea is that this takes in the shader handler again, and then we have the name of the parameter. So in this case, we're using the compile status. There's a few other ones such as delete status and shader type and things like that. Basically, what this does is this says, hey, I want to get the status of compilation for this shader, and then this is returned into the parameters here, which is why we pass in a pointer to this compiled variable. So then what we're going to do is we're going to check whether compiled is false. Because if it is, then what we're going to do is we're going to get the error of what actually went wrong. So we're going to get we're going to have the max length there, which basically, because again this is not C++, we have to do some different things. We have to go through and actually find out what the length of this log file is, and then we have to go ahead and get that. So basically what we're doing here is we're getting another variable. This time we're getting the length of the log, which if we come over here we can actually see. Basically this is checking how long the log is, and basically if there's no log it just returns 0, so this won't matter. Then what we need to do is vertex compile log is equal to, this is where we get into some fun C stuff. We have to go ahead and allocate that memory for that reading that log. And once we do that, then we can do glGetShaderInfoLog, which is a different method. What this takes in is this takes in our Vertex Shader, the length of the log that we want to read, and then we have GL size I and max length, Vertex compile log, which is where we'll actually store those characters, and then finally we're going to output that error. So we're going to say Vertex Shader error and L to kind of give us some space. Then we're going to print out that log, and then we're going to print out 2 blank lines. Finally, don't forget you need to free up that memory. One of the biggest things that you can get wrong in this, and we're going to return -1 as the error. So this isn't a key part right here, is making sure to free that memory. There's obviously other ways you could go through and do this, rather than that. I'm keeping it that way. One other thing that is, so that's how you would go ahead and do that. So that'll go through and that'll basically say, okay, if there's an error with your log, which hopefully there isn't, but if there is, when compiling your shader, go ahead and figure out the length of that log file and then actually get that log data. To kind of show that method just to make sure everyone can see that, you come over here. Basically what this method has is it takes in the shader handler again. We give it a max length for how many characters we want to read. Basically when we create this log buffer, we basically have to go through and allocate that memory, and because of that, this method doesn't know how much memory we gave, so that's where we give that here, which is the maximum amount of info to read. And then finally we have the length that is actually returned when it reads the log file. That can be, of course, used to easily figure out how much more to read, or how much was read. So there is that. So that is for our Vertex Shader. We're actually going to basically just use the same code for our Fragment Shader. So we're going to use the temp source right here again, except this time it's going to be fragment source. This time we're going to actually use our Fragment Shader. And this time instead of Vertex, it's going to be, you guessed it, Fragment Shader. Next, we're going to go ahead and we're going to take this Fragment Shader. We're going to compile it with the temp source again. We're going to then get the compiled status, which is actually going to be right there. We're going to check if it's false, and if it is, then we're going to want to go through and get the log for the Fragment Shader. We're then going to get the fragment compile log, and then we're going to read that in there. And then finally, we need to make sure we free that. We're going to go ahead and say Fragment Shader error, and there we go. So we have all of our Fragment Shader stuff there. I believe that is all the instances of Vertex Shader. We have temp source fragment. There's that, there's that, there's that. Okay, and there's all of our stuff for the Fragment Shader. The final thing, of course, will be to make it this return a separate error code so that we can detect that if need be. And then finally, if all of that was successful, we're going to return 1, indicating that this was successful. So now that we've gone ahead and done that, we need to go through and actually get up our shader link. So now that we've got the compiled code for our shaders and we have these variables stored here for vertex and fragment shaders, what we now need to do is we need to go through and compile them into our final shader program. So basically we have the compiled code, we need to link them together and actually make them an application. So what we're going to do is we're going to first go ahead and create our program. This is a pretty simple call right there. So this creates a handler, to a new program. Next, we need to attach the shaders, the first of which we give it the parameter of what the program is that we're attaching a shader to, and then we actually give it the shader. So we're going to give it the vertex shader first, and we're going to copy that, and then we're going to give it the fragment shader next. Finally, now that we have that, we can go ahead and start compiling, or linking our shader. I want to call it compiling, but it's not technically because we've already compiled. We give it our shader program, and it will go ahead and link that together. But once again, we actually have to go ahead and get whether it linked successfully, similar to our compiled from previously. So we're going to go ahead and create a parameter called linked. We're going to do get program ID, which is very similar to the previous get shader ID, except in this case it's going to be our shader program that we give it. And then we're going to do GL link status instead. Finally, we're going to store in that linked variable there. Then we're going to say if linked false. Then we're going to want to again get that unsigned integer max length, and we're going to figure out how big that log file is. So we're going to do GL get program ID, this shader program, GL info log length again, and this time it's going to be GL int times and max length. Next, we're going to go ahead and again allocate memory for log, which is going to be slightly different than what it was previously. In the previous video, I put compiled, which I'm not going to do here. It's technically a link. Max length. So now that we've got our memory, we're going to go ahead and get the program info log. And this is going to be this shader program, max length again. And this is all just going to be pretty much the same thing from before. It's really all pretty much the same at this point. Link log. So there's that. Finally, we're going to do cout program link error. And L, give us a new line there. Program link log and L to give more space. And then we're going to return -1. But again, do not forget, and I nearly forgot this there, we need to free that memory. That is a key thing here, because we need to make sure that we do not consistently suck up that memory. You might be compiling a lot of shaders throughout this. You don't want to have that memory lingering. Finally, return 1 on success. So there's our code. That'll go through and that will load all of our shaders and compile them and then link them into a full program. Finally, there's this method use. You'll notice I kind of skipped over that. That's because we need to go through and tell it to use that shader program each time. So what we're going to do is we're going to come here, we're going to create a boolean shader use, and then we're going to say if this ready, and in this case, originally what I did was I had done this program, this shader program, and then we return this ready. However, yeah, we'll just keep it like that for consistency. So basically, we check whether this is ready to be used, and then if it is, we go ahead and we tell it to use it, and then finally we return the status of this ready. And so this will basically go ahead and do that. So now that we've got our methods created, let's go ahead and open up our test state 2 here. I'm going to drag that over to this left window. We're going to just create a quick little shader to test this out. So what we're going to do is we're going to come over here. We're going to include shader. And we're just going to do shader test. And we're going to pass in our shaders. So we're going to do test.vert. And then we're going to do test.frag. These file names do not matter. They can be anything we want. But you'll notice I've already gone ahead and got 2 test shaders right in here. So we have our Vertex Shader and our Fragment Shader. So what we can actually do is we can just use those. So we're going to do test shader. We're going to copy those names, and that's going to load up our shaders. So to give an example of shader code, this is all pretty straightforward. What this has is it has a few different things. First off, we give it, and this is left over from the video I did this past week, and if you load up next video, it's going to look a little different. Don't worry, I'll go over that and everything. But basically, we give it a shader version. Remember, OpenGL's got multiple versions, most current being 4.5. We're using 3.2, so we want to have a shader compatibility for that, so we specify version 150. The versions of shaders do not match up with OpenGL perfectly, so keep that in mind. And you can go online, and I will go ahead. Let me go ahead and find that real quick. Versions, and I will link this into our into the bottom of that video. But you can see here that here kind of lines up better. But like here, for example, which is the version we're using, 3.2, it doesn't line up. So I'll go ahead and I'll link this in the video. But once you've linked that there, then what you want to do is you want to specify some inputs and some outputs. So when you're actually using the shader, and we'll go over this in the next video, basically you give it some inputs and some outputs. So the inputs are used to specify things like the position of this vertex. Remember, we just know that it's a vertex. We don't know where in 3D space it is, so that's where you pass in the position. The same thing with the color. We don't know what color it should be, and we need to actually pass that through to the fragment shader, which is why we specify this out color. Then we assign it here, and we set up the GL position variable to be equal to our position. In this case, notice that this is a 2-dimensional vector. It's not 3-dimensional, and OpenGL expects 4-dimensional vectors as a result, this usually just being 1. So then we have to specify here that this is a z of 0. So it'll be the position, and then z, and then 0, which is 0, and then 1 for the what's called w generally. So then we give our output color equal to the color variable here, and that goes into our fragment shader. Our fragment shader also specifies a version and takes an input color and then outputs a color as well. So this portion here, the OpenGL is pretty good about figuring out what is supposed to be the colors and such, though you can go ahead and change that. We're not going to worry about that for these next couple videos, but we might in the future. Again, we specify a main method just to point out that it's a main method, pretty standard stuff. And we give our output color. Again, output color is expecting a 4-dimensional vector. We only have a 3-1, so we've set the last color, which is alpha, to 1, so that we have, or opacity, which is 1, so that we see the full color. You can, of course, change that if you want it to be in transparent. So there is that. Now that we've got our shader stuff ready, let's go ahead and run this and see what happens. So if we go ahead and we run this project, it's not actually going to show anything, but what it will let us do is test whether our shader loaded properly. So if we go ahead and we load this, you'll notice it's a red screen. There's nothing outputted here. But if we go ahead and we type in gibberish here, and we then try and run it, you'll notice that we get a, whoops, I should probably do better, gibberish. Did not load it. Probably did something wrong here. Oh, I did this in test state 2. So what we actually want to do, let's go ahead and redo this. We want it to be in test state 1. So we're going to go ahead and take that there. I'm going to take this, and I'm going to undo all of that. Bring that there. Now if we go ahead and we load it, you'll notice that once we do that, everything comes up as an error because of some error codes going on there. So let's go ahead and double check what I did wrong. I probably did something very, very minor that I am forgetting to translate over. So what I am going to do is I'm going to come down a little bit. And specifically, this is a nice thing because we can actually see the errors right there. basically our Vertex Shader did not compile correctly. So it's somewhere in our compilation code. What I'm going to do to make this a lot easier is I'm going to go ahead and take all of this, and I'm just going to copy and paste this directly. This will kind of make our lives a little easier later on. We'll go ahead and compile that now. And everything compiles successfully. As to what I did wrong, let's find out. For those of you with a keen eye, you can already see what I did wrong. I forgot to actually compile the shaders. How silly of me. So let me go through and make sure I correct that. Wow, I cannot believe I missed that. We need to actually compile the shaders now. So we're going to say compile shaders. Again, this is pretty easy. Just say compile Vertex Shader because the source code is already attached. And again, change that to Fragment Shader. Now if we go through and we run this, everything will run hunky-dory. If we go ahead and we type in that gibberish again, you will notice that as soon as we do that, we get some errors about an undefined variable there. And so that's kind of the nice thing about OpenGL is that you can actually get some pretty decent error handling from here. In this case, there's no program defined because you don't have your main. So those are some of the common errors you can run into. It's all pretty easy stuff to do. And you'll notice again, nothing shows up because we haven't actually rendered any shapes. So I hope this video was a lot better. I know that my videos are definitely not perfect. And please, if you're expecting professional videos, if you're expecting these to be the best thing you've ever seen in somebody who's an expert in OpenGL, I am not an expert. I am just a guy who likes to do video games and make them and such. And I learned OpenGL to be able to do that. I really hope these are useful, though. I hope people like them. Please, please, please leave comments, leave your feedback. If you like them, give it a like, subscribe. Don't forget my Twitch stream is out there. That's always linked below as well. And I always stream every Saturday, 3 p.m. Eastern Time Standard, noon on Pacific Time Standard, 12 p.m., and then 8 p.m. GMT. It's all the same time. You can go on there, you can comment, you can ask me questions live, and then afterwards I take those videos, I make sure they're on my YouTube. I try and do them as soon as I can, and I apologize for the delays with these videos. I had to redo this one. I've got the other one that's going to be online right after this. So thank you guys for sticking with me. Thank you guys for tuning in. Thank you for those who have been correcting me and giving me feedback. I know that I've been very bad about practicing, and I promise that is going to be worked on. It's something I'm already working on, and I have that fully in mind. I've already been practicing with this stuff and making sure that these videos can be as best as they possibly can be. So thank you guys for tuning in. I hope you guys like this. See you guys next week. One more thing, again, don't forget I will be streaming my development of my own little game on the side this upcoming weekend, which is February, February 13th, 2016. I will unfortunately be gone. I'm going to be traveling to Seattle, woohoo. If anyone's there and wants to give me a shout out or something, feel free to. So I will be traveling this weekend, so I will not have a video this weekend. It will be one more week. So that is all the news for right now. Thank you guys for tuning in. I hope you guys have enjoyed these videos, and the reason I mentioned that is because in the next video it was done previously, so I say this again, I will be gone next weekend. So, but yes, more videos to come very, very soon. Hope you guys are liking them. Subscribe, leave your comments below. Thank you guys for tuning in.